Dear students, today we will solve some more problems on differentiation. Let's have a look at our next question, which is question number 116. Let f of x is equal to 3x plus 2 divided by 5x minus 3. Then d by dx of f inverse of x at x is equal to f of 1. That is what we are asked to calculate. D by dx of f inverse of x. Okay, we want the derivative of f inverse of x. Okay, first we shall find out f inverse of x. Let us say what is f of x. F of x they have given 3x plus 2 divided by 5x minus 3. Okay, so from here I have to find out f inverse of x. To find out f inverse of x, you know one shortcut, that is directly you find the adjoint of that matrix, which I have already explained in my earlier class during functions. So you can consider one matrix here, 3, 2, 5 and minus 3 here. Find its adjoint. How do I find the adjoint of a 2 cross 2 matrix? Interchange the diagonal elements. If I interchange the diagonal elements, this is what I get. And change the sign of the non-diagonal elements. Minus 2, here minus 5. This is the adjoint of this matrix. So by looking at it, you can write what is f inverse x. That is minus 3x minus 2 divided by minus 5x plus 3. Or I can also write it as 3x plus 2 divided by 5x minus 3. This is our f inverse of x. We want the derivative of f inverse of x. D by dx of f inverse of x, that's equal to, differentiate this. This is of the form ax plus b by cx plus d. Now you know one shortcut, that is in the denominator 5x minus 3 whole square, in the numerator ad minus bc, that is minus 9 minus 10, which will give you minus 19. This is the derivative of f inverse of x. We want to find the derivative of f inverse of x at x is equal to f of 1. At x equal to f of 1. Okay, let us see what is f of 1. F of 1 is equal to, put x equal to 1, 3 plus 2, that is 5, divided by 5 minus 3, which is 2. F of 1 is 5 by 2. So we want the derivative of f inverse of x at x equal to 5 by 2. So let us find that d by dx of f inverse of x at x equal to 5 by 2. That's equal to minus 19 divided by 5 into 5 by 2 minus 3 whole square. That's equal to, this will be 25 by 2 minus 3. 25 minus 6 you get, that is 19. So 19 square divided by 2 square. One of those 19 gets cancelled, 2 square will come up. So minus 4 by 19 is the correct answer, which is the second option. Then 117. If y is equal to sin x into 1 by sin x sin 2x plus sin 2x into sin 3, 1 by sin 2x into sin 3x plus etc. till 1 by sin nx into sin n plus 1 of x, then what is dy by dx? Now what I do is, I will take this sin x inside. Okay, so I can write y as sin x by sin x into sin 2x plus sin x by sin 2x into sin 3x and so on till sin x divided by sin nx into sin n plus 1 of x. Sin nx into sin n plus 1 of x. Okay. Now here don't cancel this sin x. I will write this sin x as sin of 2x minus x. Okay, Sin x can be written as sin 2x minus x plus. Here this sin x, I will write it as sin of 3x minus 2x. In the denominator, we have sin 2x into sin 3x plus. Okay, I am writing x as 3x minus 2x here, and so on. Here I will write x as n plus 1 of x minus nx divided by sin nx into sin n plus 1 of x. Okay, see here on simplification this will give you nx plus x minus nx. Nx gets cancelled, so sin x. Is it clear so far? Now here I will use sin a minus b formula. What is sin a minus b? Sin a minus b is equal to sin a cos b minus cos a sin b, that we know. So this will become sin 2x into cos x minus cos 2x into sin x, right? Sin 2x into cos x minus cos 2x into sin x. Sin 2x cos x minus cos 2x into sin x divided by sin x into sin 2x plus, here again you use the same formula, sin a minus b formula. This will give you sin 3x cos 2x minus cos 3x into sin 2x divided by sin 2x into sin 3x. Okay, are you following this? Sin a minus b formula I am using here, etc. Here again I am using the same formula. That will give you sin of n plus 1 of x into cos nx minus cos n plus 1 of x into sin nx divided by sin nx into sin n plus 1 of x. Okay, now I will split this into two terms, sin 2x cos x by sin x into sin 2x minus cos 2x sin x by sin x into sin 2x. In every term I will split it into two terms. Here in the first term let us see what happens. Sin 2x gets cancelled, cos x by sin x will remain. I will continue here. Okay, so y is equal to first term sin 2x cos x by sin x sin 2x, sin 2x gets cancelled, cos x by sin x I will write that as cot x minus second term cos 2x sin x by sin x sin 2x, there sin x gets cancelled, cos 2x by sin 2x, that will be minus cot 2x. Similarly, next term sin 3x cos 2x by sin 2x into sin 3x, here sin 3x gets cancelled, cos 2x by sin 2x is cot 2x. I will write here plus cot 2x minus cot 3x and so on. Finally, we will get cot nx minus cot n plus 1 of x. Okay, this is what we are going to get. Now when you simplify, everything gets cancelled. Observe here, minus cot 2x plus cot 2x. Here minus cot 3x, next term will contain plus cot 3x. So everything gets cancelled apart from the first term and the last term. So first term is cot x and the last term is cot n plus 1 of x. So cot x minus cot n plus 1 of x will remain. Now you differentiate it. Y dash is equal to derivative of cot x is minus cosecant square x minus of minus, it will become plus cosecant square n plus 1 of x into n plus 1. That is the answer. Y dash equal to minus cosecant square x plus cosecant square n plus 1 of x. In other words, n plus 1 into cosecant square n plus 1 of x minus cosecant square x, which is the second option. Okay. Next, 118. d by dx of x plus a into x square plus a square into x power 4 plus a power 4 into x power 8 plus a power 8 is equal to. Okay, I'll call this as y. Let y is equal to x plus a into x square plus a square into x power 4 plus a power 4 into x power 8 plus a power 8. Okay, I'll multiply and divide by x minus a. To this equation, I am multiplying and dividing by x minus a. So then you are left with x minus a into x plus a into x square plus a square into x power 4 plus a power 4 into x power 8 plus a power 8 divided by x minus a. I am multiplying and dividing by x minus a. Okay. Now here x minus a into x plus a. X minus a into x plus a will give you x square minus a square. This together will become x square minus a square. Then x square minus a square into x square plus a square. It's of the form a minus b into a plus b, that's equal to a square minus b square. So x square minus a square into x square plus a square will give you x power 4 minus a power 4. Okay. After that, here we have x power 4. Okay, I'll write one more step here. So after some simplification, we get x power 4 minus a power 4 into x power 4 plus a power 4 into x power 8 plus a power 8 divided by x minus a. Then x power 4 minus a power 4 into x power 4 plus a power 4, that will give you x power 8 minus a power 8. X power 8 minus a power 8 into x power 8 plus a power 8. X power 8 minus a power 8, these two together will give you x power 8 minus a power 8 into x power 8 plus a power 8. Again it is of the form a minus b into a plus b, that's equal to a square minus b square. So you get x power 16 minus a power 16. Then x power 16 minus a power 16, and that's all. Okay, no further expansion. So this will give you x power 8 minus a power 8. This is x power 8 plus a power 8. Their product will give you x power 16 minus a power 16 divided by x minus a. This is what we have finally. This is our y. Now we have to find out y dash. Let us differentiate this. Y dash equal to, I will use quotient rule. In the denominator x minus a whole square, in the numerator x minus a into the derivative of x power 16 minus a power 16, that will give you 16 into x power 15. Okay, minus x power 16 minus a power 16 into derivative of x minus a, which is 1. That's equal to 16 x power 16 minus 16a into x power 15 minus x power 16 plus a power 16 divided by x minus a whole square, which means y dash is equal to, here 16x power 16 minus x power 16, that will give you 15x power 16, then minus 16a x power 15 plus a power 16 divided by x minus a whole square. Okay, this is our y dash. 15x power 16 minus 16a x power 15 plus a power 16 divided by x minus a whole square, which is the first option. Then 119. If cos inverse of x square minus a square divided by x square plus x square minus y square by x square plus y square is equal to log a, then dy by dx is equal to, okay, cos inverse of this much is equal to log a. So from the given equation I can write x square minus y square divided by x square plus y square is equal to cos of log a. Cos inverse of this much is equal to log a, therefore this much is equal to cos log a. Now differentiate it, differentiating with respect to x. Here I have to use quotient rule, x square plus y square whole square in the denominator. In the numerator, x square plus y square into the derivative of this, which is 2x minus 2y y dash, minus x square minus y square into the derivative of x square plus y square, which is 2x plus 2y y dash, is equal to, on RHS the derivative is 0 because a is a constant, therefore log a and therefore cos of log a, all of those are constants, hence its derivative is 0. Now cross multiply, so this will vanish. Okay, I will take 2 as a common factor here. So 2 into x square plus y square into x minus y into y dash minus x square minus y square into x plus y into y dash is equal to 0. I'll divide by 2, so this 2 will go. Now multiply here, simplify x cube minus x square y dash plus xy square minus y cube y dash minus x cube minus x square y dash plus xy square plus y cube into y dash equal to 0. Okay, see whether we can cancel anything. Here x cube gets cancelled, y cube y dash gets cancelled. Here minus x square y dash minus x square y dash together it will give you minus 2x square y dash is equal to, then what are remaining? These two terms are remaining. Xy square plus xy square, that will be 2xy square. Take it to RHS, it will become minus 2xy square. Take this to denominator, 2 gets cancelled, xy gets cancelled. Therefore, y dash is equal to y by x. Y dash is equal to y by x, which is the third option. Then 120. If f is a differentiable function, f of 1 is equal to 0, f dash of 1 is equal to 3 by 5 and y is equal to f of e power 2x into e power x, then dy by dx at x equal to 0 is. See, they have given that f of 1 is equal to 0 and f dash of 1 is equal to 3 by 5. Fine. And they have given that y is equal to f of e power 2x into e power x. We want to find out dy by dx at x equal to 0. Differentiate this. Dy by dx. That is equal to, I will use product rule here, f of e power 2x into the derivative of e power x, which is e power x itself, plus e power x into the derivative of this. Derivative of f of x is f dash of x. So, derivative of f of e power 2x would be f dash of e power 2x into 2. F dash of e power 2x into 2. We want to find out dy by dx at x equal to 0. Find dy by dx at x equal to 0. Put x equal to 0. When I put x equal to 0, this will become f of e power 0. E power 0 is 1. So, f of 1. E power 0, that is 1. Plus e power 0 is 1. F dash of e power 0, that is 1 into 2. Given that f of 1 is 0, so this will be 0. F dash of 1 is 3 by 5 into 2. So, answer is 6 by 5. 6 by 5, which is the fourth option. Then 122. If y is equal to 1 by x minus 1 by x square plus 1 by x cube minus 1 by x power 4 and so on, x up to infinity, x is greater than 1, then what about dy by dx, they are asking. Observe here, y is 1 by x minus 1 by x square plus 1 by x cube minus 1 by x power 4 and so on up to infinity. So, if you look at these terms, you will observe that this expression, this is in GP and there are infinitely many terms. Sum to infinity of a GP, you know the formula, sum to infinity, S infinity of a GP is equal to A by 1 minus R. A is 1 by x here and R is minus 1 by x. So, y is equal to A by, A is 1 by x divided by 1 minus R, R is minus 1 by x. So, 1 minus of minus 1 by x, it will become 1 plus 1 by x. Take LCM here, x is the LCM, x plus 1 by x, x gets cancelled. So, we have 1 by x plus 1, this is y. Y is equal to 1 by x plus 1. So y dash is equal to minus 1 by x plus 1 whole square. Derivative of 1 by x is minus 1 by x square. So minus 1 by x plus 1 whole square, which is the third option. Then 123. Let f of x is equal to x into root x minus root of x plus 1. Then f of x is continuous but not differentiable at x equal to 0. F of x is differentiable at x equal to 0, not differentiable at 0, discontinuous at 0. So for this function we need to test the continuity and differentiability at 0. Okay, first we will test the continuity. F of x is x into root x minus root of x plus 1, right? Now let us say what happens to limit x tends to 0 f of x. If I directly apply the limit as x tends to 0, this will be 0 into 0 minus 0, 0 into 0, that is equal to 0. What about f of 0? Put x equal to 0, still you get 0 only, right? So f of 0 is 0, limit x tends to 0, f of x is also equal to 0. Therefore, we can say that f of x is continuous at x equal to 0. So the function is continuous at 0. Now let us verify whether it is differentiable or not. So for that, limit x tends to 0, f of x minus f of 0 divided by x minus 0. Okay, this is what we have to find out. We have to check whether this limit exists or not. That's equal to limit x tends to 0, f of x. What is f of x? X into root x minus root of x plus 1 minus f of 0 is 0 divided by x. X gets cancelled. Limit x tends to 0, root x minus root of x plus 1. Put x as 0, we get 0 minus root 1. Root 1 is 1. So this is equal to minus 1. Limit exists. This is nothing but f dash of 0. So from this we see that f is continuous as well as differentiable. So the answer is second option, f of x is differentiable at x equal to 0. Because if I say it is differentiable, then it is obvious that it is continuous also. Then 124. F of x is equal to minus x when x is negative, x square when x is between 0 and 1, x cube minus x plus 1 when x is greater than 1. Then f dash of 0 is 0, f dash of 1 is 1, f dash of 0, f dash of 1. So we need to find out f dash of 0 and f dash of 1. F of x is defined like this. It is equal to minus x if x is less than 0. And it is x square when x is greater than or equal to 0, less than or equal to 1. And it is x cube minus x plus 1 if x is greater than 1. Okay. Say, before we go for differentiability, first let us verify the continuity. Let us check whether these are continuous or not at 0 and 1. Now you may think, sir, why do we need that? It is because, say, to say that f dash of 1 does not exist. If I say if the function is discontinuous at 1, clearly you can say f dash of 1 does not exist. So we will test the continuity first. I want to test the continuity at 0. So for left hand limit you consider this, put x equal to 0, we get 0. Then for right hand limit you consider this, put x equal to 0, you get 0. Left hand limit is 0, right hand limit is 0, so the function is continuous at 0. Then to test the continuity at 1, I'll consider this. For left hand derivative, left hand limit, this is what we have to consider, x square. There you put x equal to 1, we get 1 square which is 1. Then for right hand limit, put x equal to 1 in this, we get 1 minus 1 plus 1 which is 1. Left hand limit is 1, right hand limit is 1, therefore function is continuous at x equal to 1. Okay. So that means function is continuous at 0 also, continuous at 1 also. Now let us test the differentiability at 0 and at 1. For that I have given you one shortcut, or okay, I will give you both the methods. First I will go by the actual method, then I will explain how to use that shortcut. So at 0 I want to test at x equal to 0. For that first you need to check left hand derivative. That's equal to, say, limit x tends to 0 minus f of x minus f of 0 divided by x minus 0. That's equal to limit x tends to 0 f of x is approaching 0 from left side means x is less than 0, there f of x is minus x. Minus f of 0, at 0 put x equal to 0, 0, divided by x minus 0 which is x. So minus x by x get cancelled, so we get minus 1. Left hand derivative is minus 1. Now right hand derivative, that's equal to limit x tends to 0 plus f of x minus f of 0 divided by x minus 0. That's equal to limit x tends to 0. X is approaching 0 from right side, which means x is greater than 0. Whenever x is greater than 0, f of x is defined as x square. So x square minus f of 0 which is 0 divided by x minus 0 which is x. So one of those x gets cancelled, you will have limit x tends to 0 x, that's equal to 0. Left hand derivative is minus 1, right hand derivative is 0. So the function is not differentiable at 0. So this clearly indicates that f dash of 0 does not exist. F dash of 0 does not exist is present in only one option. So that's the answer. Okay. But however, I will tell you what is f dash of 1. So now let us test the differentiability at x equal to 1. So there left hand derivative is equal to limit x tends to 1 minus f of x minus f of 1 divided by x minus 1. That's equal to limit x tends to 1. X is approaching 1 from left side. Their function is defined as x square minus f of 1 at x equal to 1. This is what you have to consider. Put x equal to 1, 1 square which is 1 divided by x minus 1. X minus 1 gets cancelled. So you have limit x tends to 1 x plus 1. Apply the limit of 1 plus 1 is equal to 2. Then right hand derivative I will find here because not enough space available. That's equal to limit x tends to 1 plus f of x minus f of 1 divided by x minus 1. That's equal to limit x tends to 1. X is approaching 1 from right side means x is greater than 1. There f of x is defined as x cube minus x plus 1. Okay, f of x minus f of 1. F of 1 is 1 minus 1 divided by x minus 1. Okay, there 1 gets cancelled, x cube minus x. So limit x tends to 1, I will take x as common, x square minus 1 divided by x minus 1. Write this x square minus 1 as x minus 1 into x plus 1. Then x minus 1 gets cancelled, you will have limit x tends to 1 x into x plus 1. Apply the limit 1 into 1 plus 1, 1 into 2 is 2. Left hand derivative is 2, right hand derivative is 2. Therefore, f dash of 1 exists. F dash of 1 is equal to 2. So, this is the answer. F dash of 1 is equal to 2. F dash of 0 does not exist. This is the actual method. Now, I will tell you what is the shortcut. Okay. Look here, we have this f of x. F dash of x you directly differentiate. Derivative of minus x is minus 1. That is if x is less than 0. Differentiate this 2x. If x is greater than 0, less than 1. Now don't write equal to 0, equal to 1. There we have to test, we don't know. Everywhere else you can write. Similarly here 3x square minus 1. Derivative of this is 3x square minus 1. If x is greater than 1. Now we want to test the differentiability at a 0. Put x equal to 0 here as well as here. If I put x as 0, it will remain as minus 1 only. Here if I put x as 0, I am getting 0. So at x equal to 0, left hand derivative is equal to minus 1. Right hand derivative is equal to, here if I put x as 0, I am getting 0. Left hand derivative minus 1, right hand derivative 0. So f dash of 0 does not exist. Then at x equal to 1, at x equal to 1, left hand derivative, here x is less than 1, right? At x equal to 1, this is our left hand derivative. Put x equal to 1 in this. Putting x equal to 1, 2 into 1 will give you 2. Right hand derivative, put x equal to 1 here, we get 3 minus 1 which is 2. Left hand derivative is 2, right hand derivative is 2. So the function is differentiable at 1 and f dash of 1 is equal to 2. That's what we have. Now we will understand why this is called shortcut, right? Okay, next. 125. If x is equal to root of 1 minus t square by 1 plus t square, y is equal to root of 1 plus t square minus root of 1 minus t square by root of 1 plus t square plus root of 1 minus t square, then what is dy by dx? Okay. So here we have x is equal to root of 1 minus t square by 1 plus t square. Y is equal to root of 1 plus t square minus root of 1 minus t square divided by root of 1 plus t square plus root of 1 minus t square. This is what we have. In this equation, I will divide this equation by root 1 plus t square. Dividing this equation by root 1 plus t square, we get here root 1 plus t square gets cancelled. So 1. Here we will have root of 1 minus t square by 1 plus t square. Here root 1 plus t square gets cancelled. So 1. Here it will be root of 1 minus t square by 1 plus t square. Okay. Now observe here. This is nothing but x. Root of 1 minus t square by 1 plus t square is x. So we have y is equal to 1 minus x by 1 plus x. I can also write it as minus x plus 1 divided by x plus 1. So y dash, now we know one shortcut for this, AD minus BC divided by CX plus D whole square. So denominator is x plus 1 whole square, numerator is minus 1, that is minus 2. So answer is minus 2 divided by x plus 1 whole square, which is the second option. Okay. Next, 126. The function f of x is equal to mod x cube is differentiable at 0, continuous but not differentiable at 0, discontinuous at x equal to 0, a function with the range minus infinity to infinity. Okay. So f of x is equal to, we have mod x cube, right? Mod x cube, just like mod x. Mod x is equal to x when x is positive, minus x when x is negative, that we know. So similarly, mod x cube is equal to x cube if x cube is positive. X cube is positive means x is positive, and it is minus x cube when x cube is negative. X cube is negative means x is negative. This is our f of x. Now continuity we want to check, right? Put x equal to 0. At 0 only we have to check. So left hand limit we get minus 0, that means 0 only, and right hand limit is 0. Left hand limit is 0, right hand limit is 0 at 0. So function is continuous at x equal to 0. Then f dash of x, that will be equal to 3x square if x is greater than 0, because at 0 we don't know what happens, minus 3x square if x is less than 0. So left hand derivative, put x equal to 0 here. If I put x equal to 0 here, I am getting 0 only. And for right hand derivative, I have to put x equal to 0 here. There also I am getting 0 only. That means this function is differentiable at x equal to 0. So differentiable at x equal to 0, first option is the answer. And fourth option, it is not correct. A function with the range minus infinity to infinity. The range of this function is 0 to infinity, because mod x cube, in fact modulus of any function can never be negative. Its range is 0 to infinity, closed at 0. So fourth option is also wrong. First option is the correct answer. Okay students, with this I will stop today's class. The remaining questions we will solve in the next class. Meanwhile, you should solve all the problems which I have left in between. Whatever the doubts you have, you can ask through WhatsApp group. And it is observed that hardly any student is asking any doubts these days. So make sure that you solve all those problems. Any doubts if you have, please ask. Thank you.